This is 3.4, factoring quadratics with a greater than 1. When we factor quadratics, we first have to look to see if the leading coefficient, or the number in front, is greater than 1. So in this first case, the leading coefficient is 2, so greater than 1. If the value is greater than 1, we can't use the same technique that we used in 3.3. We have to use a different technique. And there are a variety of techniques out there. What I'm going to show you guys to do is something called slide and divide. So first what we're going to do is we're going to take the leading coefficient and we're going to slide it over to the 3 and multiply them together. So we no longer have a number in front of the x, so it's just going to be 1x squared. The middle term stays the same, and then 2 times 3 is 6. This then looks like something that we would factor in section 3.3. And so we're going to start with looking at a factor pair list. So for 6, we're going to have 1 and 6, 2 and 3. And we want the factor pair that's going to add to positive 5 and multiply to positive 6. So if we look at 6 and 1, to get positive 5, we would have to do plus 6 minus 1. However, plus 6 minus 1 does not multiply to positive 6, it multiplies to negative 6. So this factor pair is not going to work. So we move on to 2 and 3. If we do positive 2 and positive 3, that adds to 5, and 2 times 3 gets us 6. So we're going to go ahead then and use 2 and 3. We'll put our x's in to represent the x squared, and then plus 2 and plus 3. The reason this is called slide and divide is because we slid the 2 to begin with and multiplied. We have to divide to put it back. So we're going to divide by 2. And this is the same 2. I'm going to highlight it in yellow because it's the same 2 that we slid to begin with. If the numbers divide nicely, like 2 divided by 2 is 1, then we're just going to write that number in our parentheses. If the numbers don't divide nicely, meaning we don't get an integer, then I'm going to go ahead, like 3 divided by 2 is 1.5, so that's not an integer. And I'm going to take the 2 and I'm going to pop it up here in front of the x. So I'm going to make this 2x plus 3. We can check our answer if we want using a multiplication box, or we can even graph this in Desmos to see if our original matches our answer. But that is our correct answer, x plus 1 times 2x plus 3. Let's try another example. Remember that GCFs are always a possibility when working these problems, so you have to first check always for a GCF. So if I look at 3, 7, and 4, I don't see a GCF. I also don't see a GCF with the x's. So that means I can go ahead and move on to slide and divide. So I'm going to slide the 3, and that's going to give me x squared plus 7x plus 12. And then I'm going to do factor pairs for 12. So that's going to get me 1 and 12, 2 and 6, 3 and 4. And I need the factor pair that's going to add to 7 and multiply to 12. Well, if I look at those 3 factor pairs, the pair that's going to help me the most is the 3 and the 4. So I'm going to have x plus 3 and x plus 4. Now that I've got my factors, I'm going to go back to the slide and divide technique, and I'm going to divide by the 3 that I slid in the first place. So I slid a 3 up here, which means I'm going to divide by a 3 down here. If the number divides nicely, like 3 divided by 3, then I'm going to go ahead and do that division and get x plus 1. If, like 4 divided by 3, the number doesn't divide nicely to give me an integer, then I'm going to take the 3 and I'm going to move it in front of the x. So I'm going to say 3x plus 4. Let's try the next problem. So for the next problem, we've got bigger numbers in front of the x squared, and we've got ones as our constant. So I look very quickly for a GCF. I want to see if there's a GCF that I need to factor out. I don't see one, so I'm going to go ahead and slide and divide. So I'll take the 4, give it a slide. That's going to give me x squared plus 5x plus 4. I'll do a list of factor pairs for 4. So 1 and 4, 2 and 2. I want the pair that's going to add to 5 but multiply to 4. So that's going to be, it looks like 1 and 4. So I'm going to say x plus 1 and x plus 4. And then I slid the 4. So I'm going to go ahead and divide by 4 down here in my factors. So these 4s are because of that 4. And if it doesn't divide nicely, like 1 over 4, I'm going to move the 4 up in front of the x. So 4x plus 1. If it does divide nicely and give me an integer, then I'm going to go ahead and do the division. Next example, same story. Start with looking for a GCF. I don't see a GCF either in variables or in numbers, so I'm going to go ahead and slide the 6 over to the 1 and get x squared plus 5x plus 6. And we already factored this one. We did this one above. So 6 is 1 and 6, 2 and 3. And we determined when we did it with the first example that 2 and 3 worked because it got us a positive 5 and a positive 6. So x plus 2 and x plus 3. Now I'm going to divide by 6 because that was what I slid in the original step. Now this time we have fractions that don't divide nicely, but they do reduce. So if you can reduce, you are going to reduce. So 2 over 6 reduces to 1 over 3. And then 3 over 6 reduces to 1 over 2. Once you've reduced, then you can take those numbers in the denominator and put them in front of the x. So we're going to make this 3x plus 1 and 2x plus 1. In the next two examples, we're going to have greatest common factors that we have to deal with. So 12, 4, and 40 are all divisible by 4. So I'm going to divide each of these by 4 and put that out front of my parentheses. And that's going to give me 3x squared minus x minus 10. And then inside the parentheses, I have a polynomial where I can slide and divide. So I'm going to go ahead and take the 3 and give it a slide. The 4 is going to stay in the front so that I don't forget it. And I've got x squared minus x minus 30. I'll do factor pairs for 30. So 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And I want the pair that's going to get me a negative 1. So it looks like negative 6 and positive 5 will get me a negative 1. So I'll go ahead and factor with x plus 5 and x minus 6. I still have to finish the slide and divide, so I'm going to go ahead and I'm going to divide by the 3 that I slid. So it's this 3 that I'm dividing by, not the 4 that I factored out, but the 3 that I slid in that first step. So that's going to give me 4 times 5, and 5 doesn't divide by 3 nicely, so the 3 gets moved in front of the x, so 3x plus 5. And then 6 does divide by 3 nicely, we get 2. For the next example, 18x squared plus 36x plus 16, we're going to look for a GCF. I see that it's at least 2 because all those numbers are even. Let's see if I can go bigger than 2. So not 3 because it doesn't go into 16, not 4 because it doesn't go into 18. I'd be willing to bet that 2 is our GCF. So I'm going to divide by 2 and put that 2 in front. That's going to give me 9x squared plus 18x plus 8. And I do a quick check to see if I missed another GCF. It doesn't look like I did, so I can go ahead and do slide and divide. So I'm going to slide the 9, which is going to give me x squared plus 18x plus 72. I'll do a factor tree on 72. This one is going to be a little bit of a long one. So 1 and 72, 2, and let's see, if you're not sure, use your calculator. So I'm going to do 72 divided by 2 and get 36. Then I'll do 72 divided by 3 and get 24. I can try 72 divided by 4 and get 18. 72 divided by 5 I know isn't going to work, but I can try 72 divided by 6. So that's 6 and 12. And then I can try 72 divided by 7. And that gives me a decimal, so that's not going to work. And then 72 divided by 8 is how we got here in the first place. I know that's 8 times 9. So this is a pretty long list. Let's see if we can figure out which pair is going to give us 18. So we can go through them and we can see 1 and 72 are too far apart, so I can cross those out. 2 and 36, same. 3 and 24, we're getting closer, but that's 21 or 27, so that's not it. 4 and 18, that looks like it could be 24 or 22 or, let's see, 18, that's 14, so that's not it. How about 16 and 12? Well, if I do plus 16 and plus 12, that gets me 18. So I'll do x plus 6 and x plus 12. So then I'm going to divide by 9. And again, I'm dividing by the number that I slid. So I moved the 9 here, which is why I'm dividing by 9 down here. And so that's going to give me 2 times 6 over 9 doesn't divide nicely, but it does reduce. Both are divisible by 3, so that's going to give me 2/3. 12 over 9 doesn't divide nicely, but it does reduce. I can divide that by 3 and get 4/3. And then I can move those 3's and put them in front of the x's. So we can say 2 times 3x plus 2 and 3x plus 4. On the next page, we're going to deal with some more challenging problems. Let me make that a little bit bigger. So for the first two problems, we're missing that middle term, the term that has just the plain old x. When that happens, just put it in. So I'm going to say 9x squared plus 0x minus 1. So the term is there, but it has a value of 0. And then I'm going to look for a GCF, which I don't have because 0 is one of my numbers. And so I'll go ahead and slide and divide. So I'll slide the 9 and get x squared plus 0x minus 9. Factor pairs for 9 are 1 and 9, 3 and 3. And the pair that's going to get me a 0 is if I do plus 3 minus 3. So I'm going to say x plus 3 and x minus 3. I did the slide. I have to do the divide, so I have to divide by 9. Those don't divide nicely, but they do reduce. So I can say this is x plus 1/3 and x minus 1/3. And then take those 3's and put them in front of the x. So 3x plus 1 and 3x minus 1. Same for the next example. We're missing that middle term, so we're going to turn this into 4x squared plus 0x minus 25. No GCF, so we're going to slide the 4 and get x squared plus 0x minus 100. Factor pairs for 100, 1 and 100, 2 and 50, not 3, but 4 and 25, 5 and 20, not 6, not 7, not 8, not 9, but 10 and 10. So the pair that's going to add up to get me 0 is going to be a positive and a negative 10. So we're going to say x plus 10, x minus 10. And then divide by our 4 for our slide and divide. Those don't reduce, well, they don't simplify, but they do reduce. So we can say x plus 5 over 2 and x minus 5 over 2, both divisible by 2. And then we can move those 2's over and get 2x plus 5 and 2x minus 5. For the next example, let's see what happens. I look for a GCF, I don't see one. So I take my leading coefficient, multiply it by the constant. So that's going to give me x squared plus 8x plus 16. Then I'll do factor trees for 16, or factor pairs for 16. 1 and 16, 2 and 8, not 3, but 4 and 4. I want the pair that's going to get me a positive 8 that still multiplies to positive 16. So that's going to be positive 4 and positive 4. So I'm going to set up x plus 4 and x plus 4. And I'm going to divide out the 16. So then we're going to say x plus, and that reduces to 1/4, and x plus 1/4. And then the 4's we're going to move over to coefficients of the x. So 4x plus 1 and 4x plus 1. And since they're the same, we'll go one more step and write this as 4x plus 1 squared. Okay. Next one. Again, we look for GCFs. I don't see a GCF for all 3 numbers. 2 of the 3 might have a GCF, but it has to be for all 3 numbers. So I'm going to go ahead and I'm going to slide the 9. So that's going to give me x squared minus 12x plus 9 times 4 is 36. I'll do factor pairs for 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, not 5, but 6 and 6. And I need 12. So it looks like minus 6 and minus 6 will get me minus 12. So I'll write x minus 6 and x minus 6. I notice that they're the same, so we might have something similar happen with this problem that we did before. I'll divide by the 9 that we slid in the first step. That doesn't divide nicely, but it does reduce. They're both divisible by 3, so we're going to make this 2/3 and 2/3. And then we're going to take the 2, put it in front of the x, I'm sorry, the 3 and put it in front of the x, and make it 3x minus 2 and 3x minus 2. And since they are the same two factors, we're going to write it as 3x minus 2 squared. Okay. The last two kind of put it all together. So we're looking for everything. Let's start with GCF. For this first example on the left, do we have a GCF or more than one GCF? Well, 6 and 24 are both divisible by 6, so I can divide out a 6. They also both have one x. The first one has two x's, but the second one only has one, so I can only take out 1. So if I divide out 6x, that means I'm going to have 6x times 6 divided by 6 is 1. X squared divided by x leaves me with an x. Then negative 24 divided by 6 is 4. And the x's get canceled out. And so that's all I have to do, because what's left inside the parentheses is not an x squared. It's just an x. So if we've gotten this down to just x's, we've done our job. For the last one, there's a couple of things that we can factor out to begin with. We can factor out, let's see, with 36, 48, and 15, they're all divisible by 3. So we can divide a 3. I would also suggest when the first term is negative, divide out the negative as well. So I'm going to make this negative 3 times negative 36 divided by negative 3 is 12. So we'll have 12x squared. Negative 40 or 48 divided by negative 3 is going to be negative 16. And then negative 15 divided by negative 3 is positive 5. So we check for another GCF. And I know we want there to be because of the 12 and the 6, but the 5 is prime. So unless 12 and 6 are both divisible by 5, we don't have another GCF. So then we'll go ahead and slide and divide. We'll slide the 12. So that gives us x squared minus, whoops, I forgot my x in the step before, minus 16x plus 60. So we'll do a factor pair list for 60. So 1 and 60, 2 and 30, 3 and 20. Does 4 work? I don't think so, but let's check. So I'll do a quick check on my calculator and do 60 divided by 4. Oh, it does work. It's 15. Good thing I checked. And then 60 divided by 5 is 12. 60 divided by 6 is 10. I don't think 7 works. Let's try it. 60 divided by 7, nope. 60 divided by 8, nope. 60 divided by 9, nope. And then 60 divided by 10 we have. So there's our list. I need the pairs that are going to get me negative 16. Negative 16. So I start looking through the list and I say those are too far apart. Those are too far apart. That's going to get me 23 and 17, so not quite. That's going to get me 19 and 11. That's not it. That's going to get me 17, but not 16. So it looks like 6 and 10. And they're both going to have to be minus to get me a negative 16, and when multiplying, give me a positive 60. So I will set up my parentheses. We'll do x minus 6 and x minus 10. I'll divide by the 12 that I slid. So that's going to give me x minus 6 over 12 reduces to 1/2. And 10 over 12, both divisible by 2, reduces to 5 over 6. I'm going to move those denominators so that we don't have fractions in our answers and say negative 3 times 2x minus 1 times 6x minus 5.